Welcome to Matematika. Today we're going to talk about the chains and tandem, that is part 2. And it's still under unit 1, that is polynomial and rational function. Now in part 1, we talk about the graphs of function, that is displays a set of input and output pairs and shows how the values of the functions input and output values vary. To create the graph, we have to do the verbal description. So what is in verbal description? That is where we analyze the description to understand the relationship between the variables involved. Remember how the variables change with respect to each other, whether it increase, decrease, or fluctuate in some patterns. Then after doing that, we identify the independent variable, that is the input, and dependent variable, that is the output. So when the relationship between the variables is clear, then you can determine the appropriate scale for the axis. That is when we do the graph. So the range of input and output values generate a set within the range. Remember, I did a table in the part 1, and then we put the values for the independent value, that is the input values, and then we solve for the output values. But you can generate it using the calculator. Then plot the input and output pairs on the graph to create a visual representation of the relationship between the two variables. These are the what we did in the part 1. Now in this part 2, we will focus on the basic elements of functions graph, of function graphs. So these are the features of functions. So after a function is graphed, we identify the features of the function. So one feature is the concavity. So what is a concavity? That's the curve of the graph, or the curvature of the graph. And the important characteristic of that function give the information about the function's behavior. All right. Concavity, there are two types. A graph is concave up on the intervals in which the rate of change is increasing. As we move from left to right along the graph, the slope of the tangent line to the graph increases and becomes more positive. Let's understand that. There is a graph at the right side here. Okay, let's do this. So when it's concave up, it's just like a ball that is facing up. Okay? Concave up. And it is increasing when it's facing upward. All right, let's look at the graph here. This is a concave up. We are talking about the rate of change. So how does the rate of change, if we recall, change in y over the change in x. So what is change in y over the change in x? Isn't it that is the slope, right? So what is the slope or the change in y? That is y2 minus y1 over x sub 2 minus x sub 1. That is how will we know that the rate of change is increasing or the slope of the tangent line to the graph increases? Okay, let's look at this graph. I'm going to expand. All right. Oops, I wanted to see. Okay. If you look at this graph right here, there is a line, let's say this point, that passes through the point, this line, right? Just touches the point in the graph. This is what we call the tangent line. I hope this is algebra 2. And now, what is the direction of the line? Isn't it its slant that way? That is from the left towards the right up. Okay? Left down towards the right up. And it tends to, towards the right. So the slope towards the right is a positive slope. All right. So positive to the right, to the left, that's negative. When it's straight, there is no slope. All right. So how about we draw another line passing through this point? We choose a point on the graph. This line also is a tangent line. I will make this big. And it is positive. Still, it's positive. So when it's positive, it is increasing. Right? So the slope here is increasing. That's it. Now, for example, besides using the tangent line, the question is, can we do the slope using the formula of slope, that is the change in y or change in slope? Okay, rate, that is what we call the rate of change. So, okay, let's do this. Let's try. If I choose this point right here, wherein the x value the x value is negative, what do we have in the y value? That is a negative value for y, right? Okay, so this point can be negative 2 and 2. Negative 2 in y, negative 2 in x. How about if I choose this point right here that is in the graph? What is the input value? That is positive 2, and the output value is 2. Okay, I want you to observe that 2 points right there. See, if I will make this as x1, y1, x2, y2. Okay, so x1, y1. This is x sub 2, y sub 2. So y sub 2 is 2 minus y sub 1 is negative 2. Then x sub 2 is 2. Then minus x sub 1, which is negative 2. So 2 plus 2, that's 4 over 4. So our slope is 1. our slope is positive. So that means by doing the rate of change, we know that this is positive and the rate of change is increasing as we move on with our points. Okay. The second is concave down. When it's concave down, the interval in which the rate of change is decreasing. So we move from left to right along the graph. The slope tangent to the graph decreases and becomes a negative. All right. So it's just like a ball that is facing down. Okay, face down. And this is concave. How a concave down looks like. Okay. And when it's down, we always see that it is decreasing. Okay. Let's look at what's the difference between concave up right here and between concave down. All right. Let's use the tangent by knowing if it is increasing or decreasing. Let's say these are the 2 points here in the graph, and there is a line that is drawn that passes through the point that is tangent of the line. Okay? So, what have you observed? From left up going to the right down. The line goes that way. So when the line goes that way, you know that the slope is negative. Remember in Algebra 1, I always remember this. When it's slant to the right, it's positive. When it's slant to the left side, that is negative. So we have another point here. There is a tangent line that passes through the point, touches the point. So that means it goes down. This is a negative. So when it's negative, it is decreasing. This is decreasing. Okay. Let's understand more on that before doing any a sample problem. Let's do one of the features of the graph or features of the function. Zeros. So I said concavity and zeros and the y-intercept are the basic elements of the function. So we have the zeros or zero. I will write it here. Basic elements. When we have zero, that is the graph intersect at the x value, like the zero. When the initial value of a function is zero, the graph intersects the x-axis. So intersect the x-axis. So what is our x? That is the independent value. Okay? And this is the input. So the output is zeros of the function. So zeros can be roots or solution. So x-axis when the output is 0. So what do you call this 0 on the in the independent axis that intersect? That is what we call the 0. Okay, so the input values is 0. Next is the y-intercept. The y-intercept, of course, the graph, where does the graph intersects? At y-axis. And that is y-axis, we call that the dependent. So what is the output value? We call the output value the y-intercept. Okay? So the input value here is 0. Okay. Concavity, I just write this, whether concave up or concave down. So when it's concave up, like ball facing up and down, ball facing down. So this is increasing. I'm somewhat making a summary here. And this is decreasing. All right. Let's locate the elements that we are looking for in this graph. Okay. We have the point of inflection, or what we call inflection point. That is the point where the concavity changes from concave to concave up to concave down, or concave down to concave up. So the rate of change of this point is faster than the rate of change of any points that is near to that point. Okay? So the end behavior, we can have a negative infinity. To the right, this is a positive infinity. So if we look at this graph right here, this point right here, we can tell that this is increasing. Okay, I will make this bigger. Increasing. But when it reaches at this point, the x is 0. So when the input is 0, the output, there is a value of the output, and that output is what we call the y-intercept. The point, okay, where it intersects the x-axis, this is our x, this is the independent. So this point right here, and this point is what we call the zeros. Okay? So what is a 0? It intersects the x-axis. So what is our output value there? The output value is 0 when you have an x-intercept. Okay, so the 0, sometimes we call it the roots or the solution in algebra. All right. As soon as from y-intercept, if we try to look at the direction of the movement of the graph, all right? From here, it starts to decrease, going down, decreasing. And then here, it decreased and started to increase. Okay? So this point right here is concave down. Decreasing. And this right here, this is concave up, facing up. Now, at the point right here where it start to change, the concave down to concave up is what we call the point of inflection. Okay? So what does the point inflection does? It divides the concave down with the concave up. It's just like a divider. That is a point where, the graph or the rate of change started to change. Okay? So we have the zeros, we have the y-intercept, we have the x-intercept. The zeros are the x-intercepts. Then we have the concavity, which is concave down and concave up, increasing, decreasing, and point of inflection. I think everything is here, the elements in the graph. Okay. I hope it is clear. Let's do some problem to understand a lot more, a lot better understand more, okay, with the problem. The following graph represent the water consumption for a household. The water bill, B of X in dollars, for a household is based on X 100 gallons. So the X here is in terms of 100 gallons. So if you have 2, that means 200 gallon for 400 gallons and so on of water consumed during a month. Okay. So the Y is the amount of value that you are paying. And this is B of X. All right. If the household consume 500 gallons of water during a month, what will be the water bill? What will be the water bill? So let's locate where is that 500 gallons. So 500 is somewhat like, I have to, between 4 and 5. I will extend that graph. And then I will look at the output here. So what do you think? 50 up. So let's assume that this is 70 right here. Okay. So the output, remember the Y is your output. And your X is the input. So we could say the output is 70. Okay, we could say $70, which means what do you think? the family water bill for a month, where they consume, what is their consumption? They consume 500 gallons, right? Of water. Oh, I will take that. So we find the output. All right. Oops. 500 gallons of water is $70. Okay, right here. All right. If the household receives a water bill of $95 approximately, how many hundred of gallons of water did they consume during the month? So this is the one that is given, $95. Right here. So where can we find the 95 in the graph? Somewhat near below 100. Let's say somewhere here. This is the 95. From the output, that is the vertical B of X axis, the water bill is represented. So we need to start by finding the 95 in the axis, that is the Y axis. Then we go down. Right there. Maybe, wait, I have to make my line clear. Somewhat like between 7 and 6 and 8. Oh, not so. That's more than. So if the between here is 7, so if I move down, that is between 7 and 8. Right? That is 7.5. Okay. So the water bill is represented. Look for the 95 on the fine. $95 in Y axis. Then we identify the input. We do the reverse. So the input value with the output of $95. So what is our input? Is, what do we have? 7.5. And that is in terms of gallons. So we have 750 gallons of water. for the month the family is consuming. They consume 750 gallons. All right, just looking at the x-intercept and the y-intercept. Actually, that's what we are doing in this problem. For which values of x does the water bill increase the fastest? And what does this mean in the context of the problem? All right. When we look at the graph, when we look at the rate of change or slope in each segment of the function, determine which of the segment is increasing the fastest. Okay, let's do this by segments of the graph. So I think I'm going to use different color here so that we can identify it. All right. I want to look at this segment right here. So what do we have? And this is another segment right here. It is divided into, so we have segment 1, segment 2, and then this will be segment 3. Let's look at which values of x does it, move the fastest. Okay. Let's do this. Let's use the rise over run. Since we are looking for the rate of change. Rise over run, that is the change in y over the change in x. We can use the y2 minus y1, x sub 2 minus x sub 1. So let's say I have segment 1. Okay, let's do this. Let's look at the y. Okay, I'm gonna use like which one I'm gonna use here for this segment. Okay, I'm gonna use this point 0, 0, and this point right here. All right, so I have this point as for, let's say 60, somewhere there. This will be my x1, x1, y1, and this is x2, y2. So I will write it down here. My coordinates. And then I have 460. x1, y1, x2, y2. All right. So the y2 is 60 minus y1, 0. X sub 2 is 4 minus x sub 1, 0. So I have 60 over 4 which is equals to 15. What is that? $15 per gallon, or 60, okay, $60 per gallon. Let's say, how many gallons would that be? 60 would be 60 over 4. 60, which is equals to 15, or you can have 15 over 1, that is 60 per gallon. $15 per gallon. Let's do segment number 2. Let's do the rise over run. Let's look for the points here. What will be from this point to this point? So what is the coordinate of here? We have 4 and wait a minute, I'm still looking for this point where it started to change. 4 over 60. Oops. Wait, I messed up. So in segment number 2, what is our coordinate? When it's 8 in x, we have 100. And then, which the other one point that we have? When it's 4 in x, we have 60. Okay. So our x1 so our segment, the coordinates, we have 460. And when it's 8, we have 8, 100. So this is x1, y1, x2, y2. What we're trying to prove here is how fast, okay, the increase, which one is fastest. All right, so y2 is 100 minus 60. Then for the x, we have 8 minus 4. So 100 minus 60, that is 40 over 4. We have $10 per gallon. Right. For segment number 3, the last one, because we're trying to, so what is our coordinate here? This is 8, 100. Let's say this point right here, I will have it as 14. 14 in x, then we have, how much do you think? 130? I could guess 130 somewhere right here. Okay, let's try. So our coordinates would be, 460. And we have 14, 130. So this is x1, y1, x2, y2. So 1 30 minus 100, 14 minus 4, we have 30 over, 14 minus, what do you have here? 14 in x, 14 minus 8 is not 4. Sometimes we are always like this. We have to be careful what we're doing. We mess up. Like me, when I move fast, I tend to, make mistakes. So 30 by 6 is $5 per gallon. Hundreds. This is hundreds. Hundreds of gallons. So by looking at this, okay, what do we see? We can say that the left segment is in fact the fastest, or which one is the fastest? This one, the first segment, is the fastest. So then the water bill increases fastest when the value of x is between 0 and 4. When x value is between 0 and 4, they are fastest. Let's go back to the graph. From 0 right here to 4. Because what do we have? 15, 10, and 5. Which one is, giving you $15 per 100 gallons? That means the first one, the first segment, is giving you, the fastest increase in the context of this problem. Okay. Let's do exercise 2. Example 2. Consider the following graph of function of x. Okay, as we can see the graph, we can see a concave up and we can see a concave down. All right. Is f of x increasing, decreasing, or constant at x equals x at 4? So where is x at 4? Right here. Right here. When x at 4, the slope of the tangent. So slope of the tangent. So how about we use the tangent? Okay, I'm going to use the tangent method. Tangent way. If I can see an increasing or decreasing. I think doing the tangent is the fastest way of doing it. Okay, I'm trying to draw the tangent line that passes through the point. All right. So what can you say about the tangent? Is it the tangent of the line is increasing or decreasing, or by looking at the slope of the tangent? All right. What is my example? When it's from left up going down to the right, it is decreasing. Okay, so we can look at the slope at x over 4. We see a negative, right? So we see a negative. So the slope of the tangent is negative, so that we have a decreasing at x equals 4. And we can also see the graph that for the interval of x equals 4 as the input, the values increase as the output y decrease. So which also there is, a function is decreasing at x equals 4. So we are talking about from here, from this graph right here, right? So we'll do that later. Okay. Question B. Is the rate of change at the function of x increasing, decreasing, or constant at x equals 4? Okay. Let's look at the concavity. Okay, what do we see here? Concave down. And this is concave up from here to here. Then it goes down. So maybe our inflection point is somewhere here. Point of inflection that divides the concave, up to the concave down. So recall that concavity of a function tells us the rate of change is increasing or decreasing. So if it's concave up, this is increasing, right? So when it's concave down, this is decreasing. So a function is in concave up on the intervals where the rate of change is increasing and the rate of change is decreasing in this interval right here. So we can see. At x equals 4, the function is concave down. So at x equals 4, what do we have? The function is concave down. Okay, when it's concave down, what can you say about the rate of change? Of course, the rate of change is decreasing. It's very clear. Am I right? Here at x of 4, decreasing at 4. Okay. State the interval where f of x is concave up. Okay, let's look at this. So, all right, I'm gonna put because we are looking for intervals. So this one is negative infinity, and this is the end behavior positive infinity, because we are talking about intervals right here. So in f of x is concave up, so approximately, let's just approximate, because we have infinity value here. The interval of, infinity, like the graph goes on and on and on. If on the left side it's negative infinity, and on the right side it's positive infinity. So that means we have a negative infinity, between negative infinity and, let's say somewhere here, what do we have? This is 1, 2, this is 3. Oh, it's covered. So let's say somewhere here in the middle. Okay, 2.5. And the other end is negative infinity. So negative infinity and 2.5. So somewhere in this interval here, that is concave up. Okay. For a cubic function, the concavity is switches from the point of inflection. Okay, from the point of inflection. So from here, that is the point of inflection, it changed to concave down, from up to down. So state the interval, this one, function of x, where it's concave down. Okay? So it's starting from 2.5 to positive infinity. Okay? So it's up here. I'll go back to letter C. So this is the negative infinity. Alright? And somewhere here is the location of 2.5. Okay? So this is up, concave up. And for the interval of concave down, from 2.5 right here, this time at the right end of the behavior is positive infinity. That means the interval when it's down is 2.5, between 2.5 and positive infinity. This is, we're going to go over about the end behavior. Okay, this concerns with the end behavior of a function. Positive, negative, and so on. So when we reach to this topic, you will understand more of what is going on in the end behavior. End behavior. So in unit 1, in this part 2, I have to summarize, right? So if the function is concave up, the rate of change is increasing. I might do my summary here. So if the function is concave up, the rate of change is increasing. When the function is concave down, the rate of change is, what do you think? Of course, it's down, then it is decreasing. All right. How about the graph of the graph of the function? We talked about the graph of the function, right, in the beginning. Graph of the function. So what is that? It represents the relationship of the input and output values. Simple as that. Between the input and output values. What else do we talk about? Um, how about the graph? Zeros. We talk about here the graph intersects at x-axis. So that is the zeros of the function. I think these are the um, most important, elements that we are talking about in part 2. So we are done with the unit. We are done with 1.1, that is the chains in tandem, right? I have to move up. So using the part 1 and part 2, I hope you were able to understand a lot better than before of what is going on. You can review this video and check and find out if what you think is correct. All right. In my next video, I will be sharing with you some practice problems, like problem in trying to figure out the concavity, the zeros, is it the dependent or independent of what we have taken out up in the chains in tandem, and those problems, questions that came out in the AP pre-calculus, previous AP pre-calculus exam. All right, see you in my next video. But before that, I could say this: if I can do it, so can you. Please don't forget to hit the like button and subscribe. See you.